Hello everyone, my name is Dr. Arpitha, Assistant Professor from Mathematics Department, VIGNANA VJYEC. Today I am going to discuss about the Bayes theorem. So, what is the Bayes theorem? Bayes theorem is nothing but, suppose here the statement of the Bayes theorem is, we are going to consider sample space, S is the sample space, and E1, E2, so on, E and B are the mutually exclusive and exhaustive events. Now, what is meant by mutually exclusive? Nothing but, the events are said to be mutually exclusive when they don't have any common. That is, their intersection is null set. And exhaustive events are nothing but, whenever we combine all the events, we are going to get the total sample space. Then that events are said to be exhaustive events. So, these all events, they are associated with the random experiment. So, what we are going to consider? We are going to consider sample space. In that, we are considering the events, E1, E2, so on, En, which are said to be mutually exclusive and exhaustive events. Then, we are considering A is an any event. A is an any event which occurs along with the events E1, E2, so on, En. So, A is another event which is going to exist along with them, such that if we take the intersection of A along with the events E1, E2, En, their intersection is null set. So, they are said to be mutually exclusive events. Now, the statement of the Bayes theorem nothing but, we are going to have probability of EA given A nothing but probability of EK intersection A by P of A. This is the statement of the Bayes theorem. How we are going to say happening of EK when A has already happened? This is nothing but the conditional probability. So, this is all about the Bayes theorem, where we are going to consider the events and mutually exclusive and exhaustive events along with the event A in the mutually exclusive events. Now, here one of the application of the Bayes theorem. Actually, what will happen? So, in general, the real life application of the Bayes theorem is nothing but, suppose if you take a manufactured factory and they are having some outcomes they are producing from the machines. And suppose if there are some defectives are there from the machines, if we are randomly select an item which is going to be defective, then from which machine it is going to get, we are going to get the defective, that can be obtained by using the Bayes theorem. My intention is that whenever if you pick up a defective item, so we can say from which machine the defective item that has taken. That is nothing but here. In the problem, in a manufactured factory, machine A, B, C produce 25%, 35% and 40% of the boards respectively. Let us take E1 be the event which denotes the products produced from the machine A. Products, that is boards produced by machine A. Okay. And E to be the event, boards produced by machine B. Similarly, E3 be the event, boards produced from the machine C. Now, we are considering events E1, E2, E3. They are the boards produced by the machines ABC. Okay. What they have given in the problem that from the machine A, probability of from the machine A, how much it is producing? Probability of E1 from the machine A, nothing but 25%. That is nothing but 25 by 100. Similarly, machine B is producing how much percentage of the boards? Probability of machine B producing the boards is 35%. Okay. Now, then probability of boards produced by the machine C, nothing but 40 by 100. Now, if you observe clearly that the total percentage that the machines ABC are producing, that 25% plus 35% plus 40%, nothing but totally we are going to get 100%. So, what is the first statement it is going to say? The amount of boards, the percentages of boards that is produced from the machine ABC, nothing but 25%, 35% and 40%. This is the first data. And the next, what they are given out of this production, 5%, 4%, 2% of the boards are defective respectively. What is the meaning of this one? Whatever the machines ABC are producing, out of that from machine A, we are having that defective boards are 5%. From machine B, we are having 4%. From machine C, we are having 2% of the defective bolts. So, let us denote D be the defective bolt. Okay. Now, what they have given from the first machine, from the first machine, defective. How much percentage they have given? 5%. Similarly, from the second machine, what is the percentage of defective? Nothing but 4%. Right? Now, from the machine, third machine, we are having the percentage of defective is 2%. Okay, is it clear? They have given two datas. Amount of percentage of the bolts produced from machines ABC, that is 25%, 30%, 35%, 40%. And how much is the defective bolt from the machine ABC? They have given 5%, 5%, 2% from the machines ABC. Now what is our duty? That suppose if a bolt is drawn randomly from the total production. So one person he came and he has drawn a bolt that is said to be the bolt is defective. So now he is asking, what is the probability that that bolt must be come from the machine B? So a person came from the factory. He has randomly picked up a bolt that is said to be defective. Now we want to find what is the percentage of that defective bolt getting from the machine B. So we have to find that percentage of getting the defective bolt from the machine B. Right? No. So we are having 25%, 30%, 35%, 40%. Now what is the Bayes theorem we are having? The Bayes theorem says that probability of what I want here. If I pick up third machine, E3 is a third machine, defective. D is a defective. What is the meaning? The denominator denotes that I have picked up the defective bolt, and the numerator denotes that must come from the machine B. Machine B means here E2, right? So what is the meaning of that? Already the denominator work has already completed. So initially the person he has picked up the defective bolt. Okay, the denominator work is done. What is the probability that it must be come from the machine B? So this is a notation. What is the Bayes theorem it is going to say? Probability of E2 given D equals to probability of E2 into probability of D by E2 by total summation value. What is the total summation value? Probability of E1 into probability of D by E1 plus probability of E2 into probability of D by E2 plus probability of E3 into probability of D by E3. Okay. So what are the terms we required? Already they have given the problem. We are having probability of E1 value, probability of E2 value, probability of E3 value, and also defective bolts from the machine A, machine B, machine C. No. What we are having here? Probability of E2. Probability of E2 is nothing but 35 by 100 into. Now, the how much the percentage of we are going to get defective from the machine B? That is nothing but 4%. Okay. By total summation of 35 by 100 into 4 by 100 plus how much we are going to have? 25 by 100 into, so 35 by 100 into 4 by 100 in plus 25 by 100 into 5 by 100 plus, what is the third one? That 40 by into 2 by 100, right? Now, so if we simplify numerator, we are going to get 140 by denominator. 140 plus 25 into 5 is 125 plus 40 into 8. 2 is 80. So, this is a total value. This is nothing but 140 by, what is the value we are going to get? 140 plus 80 means 220. 220 plus 125 is 325. So, if we simplify this one, 5 2 ja and 5 8 ja, 5 7 ja, 5 5 ja, right? Now, this is the probability of getting the defective bolt from the machine B. So, what is the percentage we are going to get? 28 by 75. Okay, is it clear? What is our intention here? the amount of boards are produced from the machines, data is given, and also how much percentage of boards are defective, that is also given. If we randomly pick up a bolt, so that is said to be defective. Now we have found that defective bolt has come from the machine B. What is the value we are going to get? 25 by 75. This is the application of the Bayes theorem, right? Now, next problem. So, now another problem I am going to discuss is, what is it is going to tell a businessman goes to hotel XYZ with the probabilities 20%, 50%, 30% respectively. So, a businessman is going to 3 hotels X, Y, Z. What is the probability? 20%, 50%, 30%. So, if we sum of all the values, we are going to get 100%. Okay. Now, another data what they have given, it is known that 5%, 4% and 8% of the rooms in hotels XYZ, they are having faulty plumbings. So, if we consider the hotel X, the percentage of the faulty plumbings they are having 5%. If we take the hotel Y, how much percentage? 4%. And if we take the hotel Z, it is having the 8% of faulty plumbings. Okay, this is the data they have given. Now, what is the question here they are asking? If a room is allotted, for a businessman, a room is allotted, that room is said to be having the faulty plumbing. So, firstly, a room was allotted to the businessman and it is said to be faulty plumbing. It is said to have the faulty plumbing. Now, he is asking, what is the probability that it is going to be assigned to hotel Z? That is the main chain. So, what is the first work happen? Already the room was assigned and it is said to have the faulty plumbing. Now, we have to find the amount of percentage that it is assigned to the hotel Z. This is the given data. Okay. Now, let us consider, let E be the event which denotes or assigns the businessman's going to hotels X. Okay. Let he denotes be the event, the businessman going to hotel X. Okay. Now, what is the probability? They have given 20%. Right. First of all, let us define E2. E2 be the event. The businessman going to hotel Y. Similarly, E3 be the event, the businessman going to hotel Z. So, what is the probability they have given? Probability of E1 is nothing but, how much probability they have given? 20%, 20 by 100. Now, probability of E2. The probability of businessman going to hotel Y is nothing but 50%. Right. Now, similarly, what is the probability of businessman going to hotel Z is? 30%. Is it clear? So, what they are given? Initially, they are given that the probability of a businessman going to hotels XYZ are 20%, 50% and 30%. If we sum of all the values, what we are going to get? 100%. Okay, fine. Now, let us go to the next one. Okay. Here, let D denotes the, what is the D denotes here? The faulty plumbings. D denotes the faulty plumbing. Right. Now, so D denotes the faulty plumbing. Now, let us take probability of, so already they have given that the percentage of the faulty plumbings in XYZ, that is nothing but probability of D given E1, nothing but how much percentage from the hotel X? 5%. That is nothing but 5 by 100. Similarly, faulty plumbing from the hotel Y, D by E2. How much percentage they have given? 4%. Right? Is it clear? No. Similarly, the faulty plumbing from hotel Z, 8 by 100. Okay? Okay. Is it clear? What they have given? The probability of going to the hotels XYZ and also the probability of the hotels XYZ having the faulty plumbings. In every problem, they will give all these data. Now, what they are asking? The businessman, a room was assigned randomly to him. Okay. What is happening? That room having the faulty plumbing. What the room was assigned to the businessman, that is having the faulty plumbing. And here they are asking that what is the probability that it is assigned to the hotel Z, right? Now, probability of okay, hotel Z is nothing but E3 by D. So D is already faulty plumbing, that must be assigned to hotel Z. Now, what we have to write? Probability of E3 into probability of D given E3 by total summation I equals to 1 to 3 probability of EA into probability of D by EA. That is nothing but summation value, right? What they are asking? They are asking from the hotel Z. Okay, hotel Z is nothing but 30 by 100 into next one 8 by 100 by 30 by 100 into 8 by 100. So in the numerator, what we are going to get? We are going to take the hotel Z. Now, what we have to do in the denominator? We have to sum up all the values. That is the hotel X and hotel Y and also hotel Z along with their faulty plumbings. So if we sum up all the values, what we are going to get? 20 by 100. Okay. And into 5 by 100 plus. This is the first hotel. And the second one is 50 by 100 into 4 by 100. Right. And the next one is 30 by 100 into 8 by 100. Okay. If we simplify the numerator, okay, what is the numerator we are going to get? 30 into 18 is 240. Okay, naturally the denominator is going to, we are going to erase that one denominator values. Okay, so 100 into 100 is common. So 20 into 100 nothing, 5 is nothing but 100 plus 50 into 4 is nothing but we are going to get 200 plus 30 into 8 is 240. Okay, here we are going to get 240 by what we are going to get? 540. 0 0 will get cancelled. 2 1 ja 2 2 12 by this 0 will get cancelled. 2 ja 7 ja. We are going to get 12 by 27. Okay, what is the probability we are going to get? 12 by 27. So, right, this is the probability of getting whenever the faulty plumbing assigned, it is assigned to the hotel Z. What is the probability? That 12 by 27. Now, if the same question, so what they are asking? They are asking that whether it is going to assign to the hotel Z. Suppose, for an example, in exam they will ask, in the same problem, just they will ask what is the probability of getting the faulty plumbing when it is assigned to hotel X or hotel Y. So what we have to do? There will be no change in the denominator. But what is going to happen? What we are going to have here? See here. One minute. Okay. 25 by 27. Okay. So this is the probability of getting the faulty plumbing which is assigned to the hotel Z. In case of the hotel X and Y, just we have to change the numerator values. If they ask the hotel Z, what you are going to get in the numerator? Just we have to place in the numerator value 20 by 100 into 5 by 100. The remaining part is same in the denominator. Then we are going to get the faulty plumbing assigned to the hotel X. Similarly, if they ask the hotel Y, the same thing we have to do with the respect to the hotel Y. That is nothing but we have to take the probability with respect to the hotel Y in the numerator, that is 50 by 100 into 4 by 100, and in the denominator we have to sum of all the values. Okay. But here just they are asking the faulty plumbing which is assigned to the hotel Z. That's why I have done only hotel Z. So this is all about the Bayes theorem. So what you are going to observe? What is the main important the key role played by the Bayes theorem? So whenever generally in factories n number of machines will be there, so there will be lot of production from the machines, and naturally whenever there is production is there, some fault will be there in the machines. So machine 1, machine 2, machine 3 and machines will be there. So it is not possible that if we some defect will be occur in any machine. So how we are going to sort out that defect part from that machines? So orally that is impossible. Why? Because in the factories we are going to see n number of machines will be there. So maybe there be 10 machines, 20 machines. So manually we cannot do with the generally we cannot do manually. But with the help of the Bayes theorem, we can sort out what whenever there is some defect is there. So we can sort out that from which the defective items it is going to get. So how we can say that that is the defective item that is coming from the machines? So suppose some 10 machines are there. We will observe the 10 machines, machine A, machine B, machine C, machine C. So we will find the value. In that probability, which machine is having the highest probability? So we will stick to that one machine. So okay, this machine is having the defective one. So let us sort out that machine. So we can sort out that problem from this machine. In this way, in the real life, this is very applicable. In the real life, we are going to play this Bayes theorem is going to play very important role. This is the main applications of the Bayes theorem. So we are having n number of applications Bayes theorem in real life. Either we can if we check about the business, or else in hotels, or else if we come across the in schools also. N number of applications we can observe the applications of the Bayes theorem. Suppose if you take some shuffling of cars or shuffling of the what we can say that some cars are there. So if we consider different types, so if we want to sort out the whether it may be defective or whether it may be fault, whether it is said to be some mistake is there in that one. So we can sort out with the help of the Bayes theorem. Okay, is it clear? This is the application of the Bayes theorem. Most probably in real life application, we can observe this application in real life applications. Okay, this is all about the probability and statistics. In that probability of statistics, I have discussed about the Bayes theorem application. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.